Hello, everyone. Welcome. Good morning. So, this is my first time presenting here. It was uh, being invited to present here. So, I would like to start with a personal experience, which seemed very relevant to the topic that I wanted to talk about. So, recently we were on a road trip. My son he is about 11 years old. So, he was talking about his favorite teachers, and he said something that stuck with me. Right? He said that his favorite teacher is the one that who gave him enough guidance, right? And then enough guidance so that he can explore things on his own, and enough guardrail so that he doesn't go on a wild goose chase. So I think that if agents had a voice, I'm sure they will at some point. I think they'll say the same thing about enterprise data. Right? That they want enough guidance so that they can explore, and they want guardrails so that they can act on the data reliably. Right. So that is what I want to talk about. And I also want to talk about the knowledge graph that we built at Harness, which is an attempt at giving agents access to the system in a reliable fashion so that they can act reliably. So we are moving from data access to taking action. So every enterprise wants agents to be deployed, and they want agents to be able to take action. And at the same time, that action needs to be reliable, right? They cannot give access to the agents and full access to the agents and give them full autonomy, right? We need guardrails, and for those guardrails, the layer that is missing, I believe, is the understanding. So we have access, which data platform has solved. We have action that models are getting smarter and smarter, and they will be able to solve. The missing layer in between is the understanding layer. So what do we mean by understanding? So before we get into that, I wanted to spend a few moments about the systems that have been built over a period of time, right? So we have all built systems over the past few decades, and we have systems that are working. So we have systems of record, right? Databases, the data entry systems, and systems of engagement. So we have user interfaces that we have been building, a web interface, we have mobile interface, and we have systems of automation. You have CI/CD and scripts that we automate, and there are a lot of automation systems that have been built. So all of these systems that we have been building have assumed the consumer is a human. Right? So the final action is being taken by a human. So now we have a new actor into the system that is being introduced, which is agents. So for agents, we need systems of reasoning. The agents are coming up with their own reasoning, and we need our system also to provide them discoverability in terms of how do they discover the system so that they can take reliable actions. So now, before I talk about how we build the system, I also want to talk about what is the runtime that we are dealing with. Right, every system that we have built dealt with a different kind of runtime. So in case of agents, so we have a different kind of runtime, which is this agent loop. So if you look at whether it is Cloud Code that all of us are using or any other agent that we use, it goes through this loop. It observes the system. So if you look at the autonomous agents that have been coming in, they observe the system, they reason, they act, and they verify, and they continue this loop. And if we enable the agents to be able to continue this loop using some structure, that is what enables autonomy. And that structure is the semantic layer that we want to introduce, which is the name of the semantic layer could be knowledge graph or MCP or anything else, right? So that understanding is the layer that helps the agent move from one step to another in this loop. And if you think about it, most of us have been doing this loop even without agents. Right? We do observe the systems, we reason about the systems, and we act and we verify. And all of the understanding was embedded in the documentation or in developers' heads. Right? And what we are trying to do now is how to provide this understanding at runtime to the agents so that they're able to continue this loop and take reliable actions. So before I talk about the knowledge graph, I want to spend a few moments about why this new interface layer itself was needed. So all of us know MCP. So the reason the MCP itself was required, for example, is because the API contracts embedded what resources can be accessed and how they can be accessed. Right? What was missing was, why should I call an API? So for example, if you think about it, the developers, when they are writing a system to interact with another system, so the why of calling an API was in the documentation, and the developer, when they were interacting with the system, they decide that this particular API must be called for mutating a resource or a CRUD of a resource or fetching a resource. So MCP layer was trying to solve the why for agents, right? When the agent is looking at a data system that it tries to access, it needs to know what is the why should it call the particular API versus another API, and how should it call that API, and what is the API contract, and what are the parameters that it should pass for calling that API. So the other thing I would say is, the easiest way would have been to expose all the APIs as tools to the agents so that the agents discover all of these APIs. So that's exactly what we had tried in the beginning. So that ended up costing us in terms of the context, right? So the context is our new precious commodity, at least for the next few months, probably. So to save on this context, what we learned is the agents need a more of a stable interface. They don't need all the 100 or 1,000 different REST APIs that we have. We don't need to dump all of them into the context window of the agents. What they need is actually a stable interface, which is a few verbs, and all the resources that they can discover needs to be progressively discovered. They don't need to discover all of them at the same time. So that is what a good teacher also does, right? So they don't dump all the knowledge at the same time. They actually progressively let the kids learn. So they give enough information so that the kids learn. So that is how we design our MCP v2 as well, the harness MCP v2. This was our insight, right? And I believe that the same applies to data as well. So the whatever learning we had with MCP, which is the why for APIs, it is the same why that we need to answer data systems. So if you think about how we design our databases, or how we design our schemas inside the databases, so the schema is telling us what data needs to be stored and how we access this data, but it doesn't encode the meaning of why should I access this data. So the why resides always with the developer when they're trying to access the data. So when an agent is trying to access the data, it needs to be able to discover the reason why it needs to access a particular table, or why it needs to access a particular field inside the table at runtime. So that is what we are calling a knowledge graph, right? So the why of which data must be accessed is the knowledge graph, and or the semantic layer. So I'll talk about what we have done at Harness. All right. So we primarily, so you have the raw unstructured data that is coming into the system. So we normalize that data, and every enterprise, I believe, has some domain model that they are working with, and that domain model is what is the semantic layer that needs to be encoded, so that the agents are, in fact, if you think about it, it's not just agents. It actually helps with passing on context that lived with one developer, probably the developer who has spent 6 years at an enterprise, to a new joining. When they're trying to explain this business model to the new joining, this is exactly what happens. They're trying to explain what is the model, why should they access a particular data system. So how should they access this data system? So this understanding is what we are trying to encode into the semantic layer, right? And so next, I will also spend some time on how there's a difference between having access and being able to understand what it means, right? So it's very easy for us to give access to agents, but no enterprise will give all access to agents, right? Because the agents don't really understand what they are working with. So similarly, there is a reason why, if you think about it, even in an enterprise, you have different roles for humans as well. You have developer role, you have a finance role, you have HR role. Each of these roles is provided with different access, because they understand that domain differently, and they understand how they should take actions in that domain by looking at the data. So similarly, when we are talking about agents, they need to be able to understand the domain and understand when an action is taken, what are the side effects. So unless that problem is solved, we cannot provide autonomy to agents, right? To be able to provide, and at the same time, we cannot say that we won't provide autonomy to agents, because I believe the world is moving towards that, which is enterprises do want to use agents to accelerate the actionability on any insights that they have. So I will talk about the semantic layer that we have built at Harness for now. So if you look at the semantic layer that Harness uses, so semantic layer is nothing but a set of canonical entities that the enterprise has, right? This is the simplest representation that I could come up with, which I think all of us can relate with, which is you have a service, you have a pipeline, you have a deployment, you have an environment in which you deploy your service, right? And of course, you have instance. And the way all of these different entities are related are represented by these edges. And the semantic layer is nothing but these entity types are encoded as metadata into the system, so that the agents, when they are discovering, they know how a service, they know what are the fields available in the service, what is the metadata that is available in the service, and how does the agent get access to the service at runtime. So that is encoded in the semantic layer. And similarly, the edge between the service and pipeline, for example, is encoding the meaning of how do these two entities correlate. So this correlation is also encoded in the meta layer. So that meta layer is trying to build the meaning of the data, or trying to encode the meaning of the data, so that the agents, or in fact, what we discovered is it helps humans also. If a human looks at this, instead of me giving, let's say, the 10 different APIs, one for service, one for pipeline. So if I present this, it's much easier for a human also to make sense of the system. So similarly, the relationships. So the entities are inventory of the system. Right? Relationships are the ones that actually provide meaning to the system, how two things are correlated. So this correlation of different entities. And the third thing that we did in the knowledge graph for Harness is we encoded the policy also as part of the knowledge graph. Right. So the policy into the knowledge graph brought the third guardrail, which is you have the meaning that is the entity types, you have the inventory that is entity types, you have the meaning that is relationships, and you have the guardrails that is policies. Right. So using these three things, now you can let the agents. So for example, when an agent decides that it needs to deploy a service, so the policy tells the agent whether it can deploy or not. Does it need approval? Does it need a human in the loop? Is there a freeze window that the enterprise has set up due to which it should not be deploying? So all of these can be discovered at runtime by the agent, rather than waiting for a human to tell the agent what needs to be done. So the policies also are part of the knowledge graph. Right. So with these three things, which is the inventory of entities and the relationships that provide meaning, which correlate those entities, and policies which provide guardrails to act on those entities. With these three things, the knowledge graph turns access into actionable actions, right? And the understanding layer is in between. So I'll show you a short demo of the knowledge graph. Let me quickly switch to the demo. So if you look at, let me start from the beginning. So this is the representation of the knowledge graph that the Harness has, which is all the different entities that Harness has, and all the different entity types and the relationships between those entity types. And in this case, the Harness is a chat interface that is interacting with the system. So if we go back to our initial thesis, which is we want the agent to be able to reason about the system. So if you look at the way it reasons with the system, given a user's question, it is trying to narrow down into a subgraph that answers a particular user's question. So the user's question was about what caused a spike in cost in the last 1 week, and it turned that question into which particular entities are relevant for this user's question, and it narrows down into that subgraph. And to be able to answer this, it doesn't need to go through all the different types all the different APIs that are available in Harness. Right? It can look at the semantic layer, and the semantic layer actually saves on the context window also, which is the context window is again it's the precious commodity. It's like RAM for an OS. So to save on the context window as well, the semantic layer provides the understanding of the system without dumping the whole the API data into the context window. So if you look at the results, so the data insights, so it generates two things. One is data insights, and the second is actions. So in this case, it is asking the user for permission in terms of taking an action. And that is because the service deployment, for example, it identified which commit caused this particular issue, and raising a PR, for example, it can take that action automatically, which is rolling back that PR. But once it rolls it back, it cannot go deploy it automatically because it needs to look at the blast radius of that particular deployment. So this is how Harness has been able to use the semantic layer and the knowledge graph to be able to take data platform. So I've built data platforms for the past 20 years, and it is fascinating to see how it is moving into agent platform now. Agent platform is the data platform has enabled access, and now agent platform, I believe, will enable action, where agents are able to provide actionable insights and take actions, act on those insights, right? In and I believe that is where the future is, and every enterprise will be looking for that, right? So that's all I have. Thank you.